Hey everyone, welcome back to the sliding window pattern series. In episode 1, we figured out what a window actually is, a contiguous portion of an array with a left boundary and a right boundary that slides one step at a time. Today, we write the code. The problem we are solving is called max-sum subarray of size k. Most people who see this for the first time reach for two nested loops and end up with O n times k. By the end of this video, you will solve it in O of n with a single loop and one formula you will never forget. If you have not watched episode 1 yet, pause here and go watch it first. This builds directly on top of it. Let's get into it. Before we write a single line of code, let's read the problem carefully. This is a habit worth building. Given an array of integers and a number k, find the maximum sum of any k consecutive elements. Our example, array is 2, 1, 5, 1, 3, 2 with k equals 3. So we need to look at every group of 3 consecutive numbers and find the one with the highest sum. Here is what I want you to do right now. Pause the video, look at the array, find the answer yourself. If you have found the answer, great. Otherwise, let's find it together by going through it step by step. Let's start with the solution most people write first. Two nested loops. The outer loop picks a starting index I. The inner loop sums the next k elements starting from I. We track the maximum sum we have seen so far. Notice I am initializing max sum to float negative infinity, not 0. We will come back to why that matters in the edge case slide. Now look at the inner loop on line 6. Every single time the outer loop moves one step forward, the inner loop resums k elements completely from scratch. Think about what that means for our array. Element 5 gets added once in window 215, then again in window 151, then a third time in window 513. 3 separate additions for the same number. That is pure wasted work. Time complexity O n times k. If your array has 1,000,000 elements and k is 1000, that's a billion operations. This falls apart completely on large inputs. The space complexity is O of 1, which is fine, but the time is the problem. There must be a smarter way, and there is. Here is the one idea that makes the entire algorithm click. Look at window 1. Elements 2, 1, 5. Sum equals 8. Now we slide one step right to get window 2. Elements 1, 5, 1. What actually changed between these two windows? Think carefully. Only two things changed. One element removed from the left, that is, the element at index 0, which is 2, and one new element entered on the right, which is element at index 3 equals 1. The middle elements 1 and 5 are completely identical in both windows. We do not need to touch them. So instead of re-adding 3 numbers from scratch, we just do this. New sum equals 8 minus 2, the element which we removed, and plus 1, the element which we added, which is 7. One subtraction, one addition. That's O of 1 per step. This is the formula at the bottom of the slide. Read it out loud. New sum equals old sum minus array at I minus k plus array at I. Write this down, memorize it. This formula is the entire algorithm. Let's trace through the complete algorithm on our example so you can see exactly how it works. Array is 2 1 5 1 3 2. K equals 3. Step 1. Initialize. Sum the first k elements. 2 plus 1 plus 5 equals 8. That's our first window sum. We also set max to 8. Step 2. Slide right. Remove element at index 0 which is 2. Add element at index 3 which is 1. New sum equals 8 minus 2 plus 1 which is 7. 7 is less than 8 so max stays at 8. Step 3. Slide again. Remove element at index 1 which is 1. Add element at index 4 which is 3. New sum equals 7 minus 1 plus 3 which is 9. 9 is greater than 8. New maximum. So max is now 9. Step 4. Last slide. Remove element at index 2 which is 5. Add element at index 5 which is 2. New sum equals 9 minus 5 plus 2 which is 6. 6 is less than 9. So max stays at 9. We are done. Answer is 9. One pass through the array. Every element visited exactly once. No repeated work. So O of n time. Here is the complete Python implementation. Let's walk through it step by step. Step 1. Validate input. Before doing anything, we check if k is greater than the length of the array or if k is 0 or negative. If either is true, there is no valid window, so we return 0. You could also raise a value error here. Either is acceptable in an interview. Just be consistent. Step 2. Build the first window. We use Python's built-in sum function to sum the first k elements. We store this as window sum. We also set max sum equals window sum right here. Not 0, not float negative infinity, but window sum. We will see why this matters in the next slide. Step 3. Slide the window. We loop from index k to the end of the array. On every iteration, we do exactly two things. Add the incoming element on the right, arri, and remove the outgoing element on the left, arri minus k. Then we update max sum. Step 4. Return max sum. That's the whole function. 10 lines of meaningful code. One loop, no nested loops. O of n time, O of 1 space. The test at the bottom confirms it. Pass in our example array with k equals 3 and we get 9. Strong candidates mention edge cases before being asked. Here are the 4 you need for this problem. Case 1. K is larger than the array. There is no valid window. We handle this with the guard clause we already added at the top of our function. Return 0 or raise a value error. Case 2. All negative numbers. This is the most common bug candidates make. If you initialize maxsum to 0, you will return 0 instead of the correct answer when every element is negative. Look at this example. Array equals -3, -1, -4, -2 with k equals 2. The maximum sum window is -3, -1 which gives -4. That's the best we can do. But if you started maxsum at 0, you would return 0, which is completely wrong. This is exactly why we initialize maxsum to window sum, not to 0. Your first window gives you a real value from the array. So you are always comparing apples to apples. Case 3. K equals the length of the array. There is only one valid window. The entire array. The sliding loop never executes because range k to length array is empty. The initial window sum is already the answer. Your code handles this automatically. No special case needed. Case 4, k equals 1. Every element is its own window. The answer is simply the maximum element in the array. Again, your code handles this automatically. State these 4 cases out loud in your interview. It tells the interviewer you think beyond the happy path. Let's make sure you can explain the complexity clearly because interviewers will ask. Brute force is O n cross k time. For every one of the n starting positions, the inner loop does k work. Those multiply together. Sliding window O of n time. Here is the clean proof. Every element enters the window exactly once when the right pointer crosses it. Every element exits the window exactly once when the left pointer crosses it. Total operations across the entire algorithm equals 2n. That's O of n. Both approaches use O of 1 space. We only store two integers, window sum and max sum. No extra arrays or maps. The real world impact: if n is 1 million and k is 500, brute force does 500 million operations. Sliding window does 2 million. That is 250 times faster from the same algorithm idea. This pattern is not only just for maximum sum. Once you have this template, you will use it for the average for every window, first negative element in every window, and many more variations. Let me give you the complete fixed window template as 3 rules, so you always have a mental checklist. Rule 1. Initialize. Before the loop, sum the first k elements. Set window sum and max sum both to that value. Rule 2. Add the incoming element. Inside the loop, add ARRI to window sum. This is the new element entering from the right. Rule 3. Remove the outgoing element. Subtract ARRI minus k from window sum. This is the old element leaving from the left. After both operations, update max sum if window sum is now larger. The formula at the bottom ties it all together. New sum equals old sum minus the element leaving plus the element entering. That's it. One formula, slide the window, update the sum, repeat. This is the foundation for every fixed window problem you will ever solve. Commit it to memory. Here is where we are in the series. Episode 1 is done. You know what a window is. Episode 2 is done. That's this video. You now have the complete fixed window template. Any interview question that asks for a maximum, minimum, sum or average over a fixed k-size window, you can solve it in O of n. Next stop is episode 3, variable window. This is where things get genuinely powerful. Instead of k being fixed, the window grows and shrinks based on a condition. The template changes, but the core insight is the same. Avoid recomputation. Episode 4 is the Flagship Problem, longest substring without repeating characters. It's one of the most commonly asked problems in technical interviews at every level. And after episode 3, you will solve it cleanly and confidently. That's a wrap on episode 2. You now have the fixed window pattern. Initialize the first window, slide by removing the left element and adding the right element, track the maximum. O of n time, O of 1 space. If this video helped you to understand something that felt confusing before, hit like. It helps this channel more than you think. And if anything we covered today was not clear, drop it in the comments. I read every single one. Subscribe for episode 3 Variable window is where sliding window becomes a real superpower. Learn smart, code calmly. See you in episode 3.